Alright, this is going to be the first of 3 videos for 5.5. We've been throwing around the idea of factoring and solving polynomials, and we've kind of used the idea when we talk about factoring out common terms and using the word dividing, and these are all kind of meaning the same thing. So we're going to look at another way to factor and solve polynomial equations when we can't necessarily factor using any of the methods that we have learned so far. And one way we're going to start with in video 1 is going to be called Polynomial Long Division. So first thing we're going to do is just remind ourselves how to do long division that we learned in elementary school with numbers, so that we can use the same kind of idea when we're doing this with polynomials. So I have 2 examples for warm-up. We're going to start with dividing 12 into 376. So what I know is if I look at the number 12, it can go into 37 a total of 3 times. So then what I do is I put the 3 on top and I multiply the 3 by the 12 to get 36. And then I subtract. So I do 37 minus 36. That gives me 1, and then the 6 from the end of the 376 just follows down, so I've got a 16. And then I do it again. 12 goes into 16 one time, and then I multiply 1 by 12, and I subtract, and I get 4. Now 12 cannot go into 4, so this is where we get a remainder. I would say I have 31 with a remainder of 4 over 12. So I have 31 and 4/12, which is 31 and a third. Now if I wanted to, and we learned how to do the decimals, I know that I could add a 0, which means add a decimal place, and then I can continue on. So 12 goes into 40 3 times, and I get 36, and I would get the 4 again, and I'd have to have the 0 again, and so on and so forth, and it would end up being 31.3 repeating, which is 31 and a third. Okay, so again, when I did this, I got 31 wholes. 12 goes into 376, 31 whole times with a remainder of 4 over 12. So let's look at then what we have in the next one. 34 goes into 39 one time. So then I multiply and I get 34. 39 minus 34 is 5, and then the 51 is just going to tag along. 34 goes into 55 one time, so that gives me 34. 55 minus 34 is going to give me 21, and that's that 1 on the 551 just tags along. Now 34 can't go into 211, so I have, or 221, so I have to do into 211. 34 goes into 211 6 whole times to give me 204. And when I subtract those, I get 7. So I'll get 100, excuse me, 116 with a remainder of 7 over 34. So now we're going to use this same idea in order to quote-unquote factor and solve polynomial equations. So we've done factor with quadratics, where a times c adds to b with the box. We've done, so that was when it was x squared or in quadratic form. We've done perfect sum and difference of cubes. We've done factoring by grouping. But when I can't do that, it doesn't mean that I can't factor. So we're going to first look at something called long division for polynomials. And it's very similar to what we just did with the numbers. So I'm going to divide the polynomial 2x squared minus 3x plus 4 by x plus 2 using long division. So I set it up much the same as what our warm-up looked like. And how I'm going to do this is I'm going to focus on the x in the x plus 2 and the 2x squared. My goal is to make x look like the 2x squared. So in order to get x to be 2x squared, I would have to multiply by 2 and an x. Okay? So like in our warm-up, I'm going to take the 2x and I'm going to multiply it by both the x and the 2 and place that underneath. So I've got 2x times x gives me 2x squared, and the 2x times plus 2 is going to give me plus 4x. Now in our warm-up we would subtract, so I'm going to subtract this quantity. So I've got 2x squared minus 2x squared. Those cancel. I've got negative 3x minus a positive 4x is going to give me negative 7x. And then the 4 doesn't have anything to subtract, so it's just going to pull down. So now I've got negative 7x plus 4 left. And I'm going to keep going until I can't go any farther, just like I was doing in my warm-up. So now I'm going to try to turn x into negative 7x. So I would multiply by minus 7. So now I'm going to take this minus 7 and multiply it by the x and the plus 2 and put it underneath what I have here. So I have negative 7x minus 14. And again, I'm going to subtract that quantity. So I've got negative 7x minus a negative 7x cancels those out. Positive 4 minus a negative 14 becomes positive 4 plus 14, so I get an 18. So now my goal would be to turn the x into an 18, but I can't turn an x into something that doesn't have an x. So this becomes our remainder. So the answer to dividing 2x squared minus 3x plus 4 by x plus 2 equals 2x minus 7, that's how many full times it goes in, plus my 18 over x plus 2. In our warm-up, we would take our remainder and divide it by what we divided by, and it was a number in that case. This case, it's x plus 2. So this would be my answer. We're going to do a couple here so that you can kind of catch the gist a little bit before I ask you to practice. All right, let's try another. We're going to divide x cubed plus 2x squared minus 4x plus 6 by x minus 1. So I want to turn x into x cubed, and I'm going to do that by multiplying by x squared. So now I'm going to take that x squared and I'm going to multiply it by both pieces and put it underneath. So I've got x squared times x is x cubed. X squared times negative 1 is negative x squared. The big thing here is when we go to subtract that you remember that you have to do it with like terms. So I've got x cubed minus x cubed, which cancels. I've got a 2x squared minus a negative x squared, so that's 2x squared plus x squared. Gives me a 3x squared, and these two pieces just come down because they don't have anything to subtract with. So I've got minus 4x plus 6. And I'm going to do this again. So now I need to turn 3x squared, or x into 3x squared. So I'm going to multiply by 3 and an x, because x times 3x gives me 3x squared. Okay, and then 3x times negative 1 gives me negative 3x. And I'm going to subtract that thing. So the 3x squareds cancel, and I've got negative 4x minus a negative 3, so that's plus. So negative 4 plus 3 gives me negative x, and the 6 just tags along. Okay, so now looks like I can do this one more time. I've got to turn x into negative x. So I'm going to multiply by negative 1. So it's going to give me negative x plus 1, because negative 1 times negative 1. And I'm going to subtract. So these cancel. I've got 6 minus 1 is 5. Now I cannot turn x into 5, so the 5 is my remainder. So I get x squared plus 3x minus 1. Oh, that's a plus 5 over x minus 1 as my solution. I'm just going to erase here a little bit so that we can see the next problem. Okay, so now we're going to go a little bit more complicated, and I want to divide 3x to the fourth minus 5x cubed plus 4x minus 6 divided by x squared minus 3x plus 5. So I'm still focusing on the first term, the x squared, and the first term underneath here, the 3x to the fourth. I want to turn x squared into 3x to the fourth. So if I multiply by a 3 and an x squared, I should get there. So now I have to multiply the 3x squared by all three pieces. So I've got 3x squared times x squared. Let me just erase here. And that's going to give me 3x to the fourth. 3x squared times negative 3x is going to give me negative, not negative 3, negative 9 x to the third. And then 3x squared times 5 is going to be plus 15x squared. So now when I subtract, 3x to the fourth minus 3x to the fourth cancels. Negative 5x cubed minus negative, so that's going to be plus. Negative 5 plus x cubed plus 9x cubed gives me a 4x cubed. Okay. And then I've got, you'll notice I put in a 0x squared. Oops, I forgot my x here. Just for a placeholder. But I have 0x squared minus 15x squared, so it's going to give me negative 15x squared, and then the 4x and the minus 6 just tag along. Okay? Excuse me. So now I'm going to do this again. I'm going to turn x squared into 4x cubed. And I'm going to do that by multiplying by a positive 4x. So now I multiply that 4x by each of the three pieces and place them underneath. So I've got 4x times x squared gives me 4x cubed. 4x times negative 3x is negative 12x squared. And 4x times 5 is 20x. And I'm going to subtract the whole quantity. So I've got 4x cubed minus 4x cubed is 0. Negative 15x squared minus a negative, so that's plus. Negative 15x squared plus 12x squared is negative 3x squared. 4x minus 20x is negative 16x, and the negative 6 just tags along. Alright, looks like I can keep going. So I'm going to now multiply. I want x squared to turn into negative 3x squared, so I'm going to multiply by negative 3. Now that negative 3 goes to each of these three pieces. So I've got negative 3 times x squared, negative 3x squared. Negative 3 times negative 3x gives me a positive 9x, and a negative 3 times 5 gives me a negative 15. I want to subtract the quantity. So negative 3x squared minus a negative, so it becomes plus, and they cancel. Negative 16x minus 9 becomes negative 25x. Negative 6 minus a negative 15 becomes a plus 9. Now I cannot turn an x squared into an x. So this whole negative 25x plus 9 becomes my remainder. So my solution is 3x squared plus 4x minus 3, excuse me. And then plus a negative 25x plus 9 over what I divided by. So I divided by x squared minus 3x plus 5. So what I'd like you to do is try the last one yourself and enter what your solution is when the question bubble pops up.